Hi everyone, David Blakey. This Python video is entitled Python Try Except. Exceptions are errors that Python detects and reacts to, or we can say responds to. Errors are endemic in programming. All programmers make errors, and they make errors every day. Errors are how we get programs made. We write a number of lines of code, and many of them may execute properly, but eventually we're going to run into an error. And errors are something I'm sure you're already familiar with. It's quite easy to make an error. We can, for example, divide an integer by 0. That'll give us a zero division error. Of course, no language or no language wants you to divide by 0. That's a cardinal error. But it doesn't really cause a problem. Python simply detects the error and then throws an exception. We say that it throws an exception. The zero division error is the name of the exception. Anytime we have an error in Python, even if it's as simple as forgetting to close a string, here we're forgetting the end quote in our string, we'll get what's called a syntax error, which just simply means syntax simply means we didn't write it right. We missed something. And the syntax is missing something. So when Python detects that sort of error, it simply throws a syntax error exception. Exceptions are the way Python can tell us when something is wrong. But sometimes we want in our programs to handle exceptions. We want to catch exceptions. We call it handling exceptions or catching exceptions. It's just something that we do and do easily and quickly using the try except syntax. It's try except feature in Python. So let's do that right now. I'm going to open up program. Now what we want to do is create an error of some sort and then handle the error. So again, if I'm concerned, let's say that one of my values in a division operation might be 0, if we can imagine that this information or this value came from some source that we can't control. For example, input 1 and input 2 might have come from the user. If input 1 and input 2 come from the user, and then we go ahead and divide one into the other, we might have a problem if input 2 is 0. Now clearly here it is 0, but if we don't know what it is, we're not sure what might have been coming in from the user, then we go ahead and do this division. We might want to be prepared for the possibility that input 2 is in fact an integer. Is in fact 0. If it is 0, then we're in trouble. And what we don't want to have happen is what would happen if we didn't try to handle the exception. Python would throw the zero division error. Now, there's nothing particularly wrong with an exception, and we certainly shouldn't be afraid of them because we're going to be running into them all the time. But when we've written our program, we've debugged our program, and our program is considered to be mostly error-free, we don't want Python to be throwing exceptions that bubble up, as they say, bubble up to the user. We don't want Python, for example, to be telling us there's a problem in line 6. Here's the line. Oftentimes when we're writing programs for outside consumption, either consumption by the public or possibly by another user, or possibly by some user that we're not familiar with because we've written a library module for someone to use, we don't want exceptions to just bubble up to the user. Instead, we want to handle the exceptions. We want Python to fail gracefully. Or perhaps we just want it to go back and say try again. For example, perhaps input 1 and input 2 are taken from the user and we try the division. The division ends up with dividing by 0. We might want to say to the user, you know what? Input 2 can't be 0, so please try again. In other words, we want to be able to handle the error and let the program continue executing. Of course, when an exception comes up that's handled by Python, execution stops, right? The program terminates right there. Perhaps we don't want that. Perhaps we want to give the user a chance to try again. I'm sure you've been You may have logged on to a system. Of course, we do this all the time when we try to sign into our bank. If we misspell either the username or the password, the page comes back and it says that was a mistake, try again. Now, of course, on the web, it's a little different, but our program may want to do that as well. So we can go ahead and do that by catching the exception. Now this is just a stub, so obviously we want to complete the program by allowing the user to type in from, may say, raw input or possibly from the command line, and then we would process it properly. But we're just going to use this as an illustration. You can see it's saying print, no, second value can't be 0, try again. What we're doing there is we're not allowing Python to catch the error. Notice the except zero division error. What's going on there? Well, we figured out what the error was. We went ahead and you can go ahead and simulate the error as I did earlier. 5 divided by 0. There's us trying to divide by 0. We went ahead and just replicated the problem to see what happens. And we can see that a zero division error results. So that's why we have zero division error here after except. Except will catch this type of error. If another error should occur, it won't catch it. And generally, that's what we want. We don't want to try to catch just any type of error. We want to catch a specific type of error because we want to know that we're under the right condition, right? The particular type of error that we were looking for has occurred, and now we can offer a descriptive message. Second value can't be 0. Try again. You can see what's going on here. For one thing, we're keeping the program from stopping. For another thing, we're telling the user in a user-friendly way what they should do. Try again and make sure that your second value isn't 0. And we might do whatever we want after that. We might choose ourselves to terminate the program, or we might just omit that part and say program continues to show that the program will then continue and isn't stopped by the zero division error. Let's try this program and see what happens. Okay, well, the error occurred, and thus this zero division error block was executed. You can see that these are blocks, right? This is the try block. We've, as they say, wrapped the problem code or the possible problem line of code in a try block, and then we placed the action to be taken in the except block. That's what we did. You can tell they're blocks, of course, because they're indented. So the try block says result equals input 1 divided by input 2. We know that the user, according to us, it would be the user. We've just, manually created these values. The user has given us a bad value for input 2. And so dividing by 0 is a no-no. So we catch the exception and then handle it gracefully. No, second value can't be 0, try again, and then program continues. You can see what's going on down here. So that's how exceptions work. So if you wanted to catch an exception of a different type, we've looked in our program and in our homework, we're looking at catching a different type of exception. You would simply identify the exception, put the code that you know may result in that exception in the try block, put the code that you'd like to result if the exception is, or if it occurs, in the except block, and then have the program do what you'd like in the except block. I'll show you that the except block doesn't get executed if we give it proper value. Here we could say print result. So what do we get then? 5 divided by 3 is 1. Well, we're getting floor division here, but as you can see, it says program continues and 1. We got nothing here. No, second value can't be 0. Why? Because the exception didn't occur. So the except block clearly only occurs when a zero division error is detected, and only when it's detected in the try block. I could show you here that if we put 4 divided by 0 up here and try running that, we end up with a zero division error. Why? Because the exception happened before the try block. I could put it after the except block clearly not part of the except block, right? Because we went back to the left margin. Run it again, and you can see again, zero division error occurs. The original division worked, input 1 divided by input 2. That worked. So since there was no zero division error within that try block, the except block did not get executed. And then we went ahead afterwards and did a division to 0. And that's where the exception, excuse me, and that's where the exception occurred. So you can see then, therefore, categorically, that the except block will only execute if the error is achieved or is encountered within the try block. And that's what a try block is for. So sometimes when you're reading some documentation, it'll say, well, you can test for this by wrapping the line in a try block and then catching this sort of exception. And that's what's going on when we talk about try and except. That's what's going on when we talk about catching our own exceptions.